Okay, so hello. So we'll begin our lecture on crustal deformation and mountain building, and then we will pick up with this on Monday when we meet again. So we're not going to go too far into this, just because um, there's. I'd rather do most of this in person, but we at least get started and make some headway on it. So, in this lecture, we're going to learn about the different processes that occur to create different deformation structures that we find in the uh, in the crust, and also the different processes, tectonic processes that result in different mountain building events. So first, to understand crustal deformation, we have to understand what causes it. And the cause of it is stress. And if you remember stress, we talked about this when we were talking about metamorphism. It's a force, which is a push or a pull, and if this stress that's imposed on a rock, if it exceeds the rock's strength, the rock will change shape. It will deform. Now, there's two types of stress. There's confining pressure. If you remember, that's when the pressure is equal in all directions. And there's differential stress. The stress is applied unequally in different directions. And so, whenever a rock is subjected to stress, as I said, it will deform, and that deformation we call strain. So strain is another term for deformation. So strain is a change in shape of a rock due to differential stress. It's another term for deformation. Now we're going to look at the different types of differential stress. Remember, differential stress is stress when the pressure is larger in one direction than the others. The first one is compressional stress. So this is a squeezing of the rock. So the rock has these two opposing forces that act toward each other, and this causes the rock to shorten in the direction that it's being squeezed and elongate in other directions. Now, compressional stress is a very common type of stress found along convergent plate boundaries. The next type of differential stress is tensional stress. This is when the rock is being pulled apart, okay, in opposing directions. And so this type of differential stress is commonly found along divergent plate boundaries. And finally, we have shear stress, where we have parallel forces that are offset, shearing the rock. And the shear stress is usually found along transform plate boundaries. Now, whenever a rock is subjected to stress, it undergoes a strain or deformation. But there's three different types of deformation, or three different types of strain. The first type we'll mention is elastic deformation. Elastic deformation is the type of deformation where the material, it deforms continuously. That means it doesn't break or fracture. And that whenever, elastic deformation, it usually occurs when there's only a small amount of strain or a small amount of deformation. What makes it elastic is whenever the stress is relieved, the strain is recovered, which means the material returns to its original shape. Okay, just like a rubber band is elastic or a spring is elastic. If you deform them, if you apply stress to them and they accumulate strain, you let go of them, being elastic, they return to their original shape. Next is brittle. So this is not continuous deformation. This is discontinuous, which means that the material breaks, it cleaves or fractures. So whenever the strain exceeds the elastic limit of the rock can break, and this breaking of the rock is known as brittle deformation. So common examples of brittle deformation: the breaking of glass or ceramic, or if you stretch out rubber band enough and it finally snaps, right? Whenever you are deforming rubber band, that was elastic deformation, but you reach a point where it can't deform anymore elastically and it just snaps. And so that's where it transitions from elastic to brittle deformation. Now, most rock, especially near the surface, it's elastic up until a point, but if it's deformed too much, it will undergo brittle deformation and break or fracture. And finally, we have ductile deformation. So ductile deformation, like elastic, is continuous, which means that the material changes shape without breaking or fracturing. But unlike elastic deformation, whenever you relieve the stress, the material does not return to its original shape. It remains permanently deformed. So common examples of materials that undergo ductile deformation are clay, or if you ever smashed a coin on the railroad tracks, put it on railroad tracks and allowed the train, when a train goes by, to smash the coin, or if one of those tourist things where you put in a quarter and you turn the crank and it flattens a penny and put some pattern on it. So those are examples of ductile deformation. Now there are several factors that influence rock strength and determine whether it will undergo elastic, brittle, or ductile deformation. And those factors include the temperature of the rock, the amount of confining pressure the rock is under, the type of rock, and the time frame at which the stress is applied. Looking at the temperature, when the temperature of the rock is high, which is deep in the crust, so not shallow crust, but deep in the crust, the rock deforms more easily. And so the warmer rock is, the more likely it will undergo ductile deformation and bend and fold when the stress is applied, rather than break and fracture. So what this means is deeper rock in the crust it's warmer, and therefore for that reason it's more likely to undergo ductile deformation, where rock that's shallow in the crust at or near the surface, it's cooler and it's more likely to undergo brittle deformation than ductile deformation. Next is confining pressure. When the pressure is large, which is also the case deep in the crust, the rock is said to be held together more by that confining pressure, and so that when a stress is applied to the rock at large pressure, it is less likely to break and more likely to bend and fold or undergo ductile deformation. So the deeper the rock is, the more confining pressure it's under, and the more likely it is to undergo ductile deformation. Where the shallower a rock is, the closer to the surface it is, the less confining pressure it's under, and the more likely it is to undergo brittle deformation, crack or fracture. Next is the rock type. So crystalline rocks, rocks that have intergrown mineral crystals like igneous or metamorphic rock, they're very strong, and so they tend, whenever they're deformed, not to undergo ductile deformation, but rather they tend to break, fracture, experience brittle deformation. While weaker, softer rocks, such as sedimentary rocks, they're more likely to undergo ductile deformation because they're more easily deformed than the igneous or metamorphic rock, and so they're more likely to bend or fold. Sedimentary rocks are. And then finally we have time. The rate at which the stress is applied. If the stress is applied very gradually, like on geologic timescales, the rock will tend to undergo ductile deformation. However, if the stress is applied very rapidly, the rock will tend to undergo brittle deformation. And so, it's just like if you have a paper grocery bag with groceries in it. If you grab hold of the handle and lift up slowly, you can lift up the bag of groceries with the handle intact. You're applying the force, the stress on the handle at a slow rate. Where if you grab that handle and just yank up, pull it up real quickly, the handle breaks, it rips, because you applied that stress very rapidly. So you can see that material responds to the stress differently depending on the rate at which it's applied, and rock does the same thing. The more rapid the rate the stress is applied, the more likely it is to undergo brittle deformation, and the slower the rate the stress is applied, the more likely it is to go ductile deformation. Excuse me. So I think we'll leave it there for now, and we'll pick up on the actual structures formed by this deformation, mainly ductile deformation. First, we'll start with folds when we get together next Monday. So once again, I'm sorry for not being able to make it in class on Wednesday. Hopefully this is some sort of stopgap between now and then. It's better than nothing, but I'll see everyone on Monday. Thank you very much.